Hello, everyone, and welcome to our presentation. My name is Janine Donnelly. I am the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. Today's webinar, Introducing LPAR Sets, Save Your Most Expensive MSUs, Soft Capping Optional, is sponsored by ThruPut Manager. Our featured speakers today are John Baker and Selby Shanley. John is a ZOS performance specialist with over 20 years' experience as a user and consultant. He has assisted many of the world's largest data center customers with their ZOS performance challenges. John has held area chair positions with CMG and is a popular speaker at CMG, Share, and IBM conferences. Selby is a principal designer and developer of ThruPut Manager Automated Capacity Management and is MVS Solutions resident subject matter expert. Selby is steeped in mainframe technology and is well known globally as a ZOS, JES2, and WLM expert. Today, John and Selby will introduce LPAR Sets, a flexible means to ensure capacity is delivered when and where it is needed, all while controlling CPU consumption where it provides the most financial benefit, with or without capping. With our introductions complete, John, I will turn the presentation over to you.
Thanks, Jean. And thank you, everyone, for attending. I see we've got a lot of people across time zones today, so we really appreciate you being with us. We're going to do a quick review of subcapacity pricing, not spend too much time on that, a little bit of review of soft capping, which most of you should be familiar with, and then we'll do a brief ThruPut Manager overview for some of our new audience members that might not be familiar with the fundamentals of ThruPut Manager. But we're going to spend most of our time talking about the automated capacity management function within ThruPut Manager automation. A bit of review of how ACM works, how it can lower your 4-hour rolling average, and then we're going to focus on the new function that Selby has developed, ACM LPAR Sets, and he's going to go through a number of examples of how you can use LPAR Sets to lower your 4-hour rolling average in your installation. At the end, just talk a little bit about how much you can save, how we can look at some of your data, and as usual, we'll have lots of time at the end for your questions. Just a quick review of subcapacity pricing. Most of you should be familiar with subcapacity pricing by now. It's been IBM's primary offering and how software is built for well over 10 years. The main point here is simply that subcapacity pricing is a consumption-based model. So anything you can do to reduce your consumption saves money, and that's what we really like to focus on. Now here we've got a sample workload license charge tiers table. The idea here is just to give you an idea of how much money we're talking about. As you can see, each software product is individually priced, and the charges are cumulative based on your consumption, once again. Again, we're talking about a lot of money here. In this example, we've got a single CPC with a rolling 4-hour average peak of 1,000 MSUs. If this particular installation was licensed for the 5 products listed there, that would cost well over $660,000 per month, just the workload license charges for those products. So again, we're talking about a lot of money here. Incidentally, I'm just going to mention at the bottom of the slide there, country multiplex pricing. That was announced, generally available as of last October. Some of you might be looking at that. It does add additional tiers, so your incremental rate will continue to go down for larger installations. But as they say, that story is for another day. Now, I want to talk a little bit about what is a peak. The term is used generically sometimes when you think, if you were to answer the question, well, when is my peak? Well, my peak, I would say, is 2 o'clock in the afternoon on the last Friday of the month. Well, what peak are we talking about? In the chart here, you can see what I've labeled as the CPU peak. That would very likely be the highest utilization when the machine is at its busiest and performance is potentially an issue. But when we're talking about costs, we're talking about a 4-hour rolling average peak, which is a much slower moving line, the dark blue line across there. And as you can see in this example, the 4-hour rolling average peak didn't occur until 1 o'clock in the afternoon, fully 3 hours after the utilization peak. The point being here is if you want to control your costs, you can't just look at the 4-hour rolling average peak individual interval. You can't even just look at that hour. You actually want to look at the previous 4 hours, exactly as the term suggests. So if your 4-hour rolling average peak was at 1 o'clock, as in the example here, you actually want to look at all of the work that ran going back to 9 o'clock in the morning up until 1 o'clock, because all of that work, regardless of its profile or its priority, contributed CPU time, which means it contributed to your software bill. Now, one of the more common methods to control software costs is with soft caps. There are a couple of options that IBM provides. Originally, they came up with defined capacity. That runs on a single LPAR. Of course, the benefit of this is your invoice will be based on the 4-hour rolling average peak or the cap limit, whichever is lower. So you would not be charged if your 4-hour rolling average were to exceed the actual cap limit. Now, there can be some penalties for that, and we'll talk about that in a second. The other option is group capacity, or LPAR groups, as they're often referred to. That allows you to set a single limit for a group of LPARs on the same machine, and again, the same rules apply. If your 4-hour rolling average exceeds that group limit, then the LPAR or LPARs would be capped, and this can affect the performance of all your workloads. My point there about granularity is that the entire LPAR is capped by Prism. You don't have any direct control over which applications would be impacted by the soft capping. Now, sometimes the effect of the 4-hour rolling average exceeding a soft cap is referred to as hitting the wall. And it's kind of like the effect you see here. What I've got is a machine with 2 LPARs, and you can see with the purple and the green lines there, the consumption in MSUs from those 2 LPARs on the same machine. And then the dark blue line represents the combined 4-hour rolling average on the machine. As you can see, the consumption of those LPARs can freely exceed the soft cap limit. That's the dark black line going straight across, until the 4-hour rolling average exceeds that limit. When that occurs, then the consumption is capped. And the consumption is capped until the 4-hour rolling average comes back down again. And as you can see, it continues to rise. The average continues to rise because of the high consumption in the previous intervals. Remember, we're accounting for the previous 4 hours. So in this example here, all of the workloads were potentially affected for over 2 hours. And what shops often end up doing in such an event is they raise the cap in order to provide relief, stop the phone from ringing essentially, and allow the applications to run again. Because the effect of being capped is very much like being a smaller machine for this period of time. Of course, the problem with raising the cap is then you've now defeated the purpose of capping in the first place, because you're going to raise your software bill along with that. So rather than capping, what if you could reduce demand, as said here? This would lower your 4-hour rolling average and your resulting monthly license charges. Now, what would you reduce if you did have this control? I think it's fairly obvious from what we're saying here. You can't really reduce online transactions where you've got a human being, potentially paying for a bill at a restaurant or paying for a shopping bill or something like that. They're waiting for a response. You can't delay that. Even TSO, you've got developers that are doing work. You don't want them staring at a clock on the screen no more than any of us like staring at a clock when we're Googling something. But batch runs in minutes, hours, sometimes even days. So small reductions that can reduce your 4-hour rolling average and save MSUs without having a dramatic impact on the runtime just makes sense to target that particular workload. It also contributes, whether you might know it or not. Quite often when we talk about peaks, we also talk about what's driving the peak. We hear the term, well, my online drives my peak because it's at 2 o'clock in the afternoon. Well, what does that mean? Drives might refer to, well, it's the largest component of the workload. And in many examples, I'm sure that's the case. What we have here is a chart from a customer only showing the daytime. Each bar represents a single day in the month, and we're showing the breakdown of the batch and the online and the system workloads. Not individual service classes here, but just general categories. We know that lots of batch runs at night, but during the day, as you can see here, there's still a significant batch contribution. Just because it's running at a lower priority doesn't mean it's not consuming CPU or MSUs in this case, and it is contributing to your software bill. And again, it's the most likely workload that you can defer. Now, what about doing this yourself? Well, there's WLM initiators might seem like a good idea because they will automatically adjust to conditions. But WLM initiators are designed to adjust to utilization. They're not sensitive whatsoever to the 4-hour rolling average, which is, again, what you're being billed on. So they're not going to make any difference at all. Manual operations, you can have operators that start and stop initiators on the fly or change classes. Maybe you manually hold and release certain jobs. We do have some large customers that have tried to do that in the past. It really doesn't work because the point is not that you're not very capable or that your staff is not very capable. It's that you can't keep up with the machine. Your workload demands, especially with online and things like that, coming in fast and furious and unexpected, you suddenly have large changes in utilization and in workload demand. Maybe something happened on the machine, which has taken away some of your capacity. You have a WLM policy adjustment interval every 10 seconds. So the point is we simply can't evaluate all of the information that's coming in and then react at machine speed in order to make sure that the right work runs in the right place at the right time in order to meet business needs as well as control costs. So we have to automate this, and this is where ThruPut Manager comes in. So again, for those of you new to our audience that are not familiar with what ThruPut Manager is, I'll just take a few minutes to describe what ThruPut Manager is all about. ThruPut Manager is enterprise software. It runs as a started task on each LPAR. It's connected and interfaces with JES2 and WLM, automates all of your batch from start to finish. So when a job is first submitted, whether from a scheduler or from a user, as soon as it hits the JES2 internal reader, ThruPut Manager will intercept that job and start managing it. Now, it has two primary automation components within our ThruPut Manager automation. The first we refer to as Service Level Manager, or SLM. This is the automation engine within ThruPut Manager that provides automated initiators, puts all the work into a single queue, into a single class, automatically orders all the work by business need, business importance, or urgency. And this is automatically reviewed and reevaluated every 10 seconds, just like a WLM policy adjustment interval. So when you're not busy, maybe you don't care. But when your system does get very busy, what this ensures is that the most critical work always runs first. And by automating those initiators in the queues, you can meet those goals. We're going to talk mostly about automated capacity management today, though. This is the component that deals directly with the cost aspects. SLM is already going to make sure that you meet your business goals. What ACM allows you to do is meet your budget goals by lowering that 4-hour rolling average and giving you the ability to selectively control what workloads are constrained rather than capping an entire LPAR. So as I just mentioned, ThruPut Manager Automation will analyze the utilization of the machine and all of the LPARs every 10 seconds. We'll analyze the workload performance and importance. So for the techies in the room, what we're doing, we're looking at velocities. We're looking at the performance index of your workloads. And we're making decisions about when and where work should run. We're also aware of any specific system affinities or resources requirements for all the batch workloads so they run on the right systems. But in addition to that, what automated capacity management will do is it will be aware of any soft caps. So if you've got defined capacity or group capacity limits, ACM knows that they're there. It knows what the limits are. And if you change them, it will know what they are again. You don't need to define that. We're aware of the 4-hour rolling average on each LPAR and the current CPU consumption, so we can track trends. And if you specify a 4-hour rolling average target, we'll be aware of that. Selby's going to talk more about that later, where you can have a target limit without a cap, and ACM can constrain your workloads accordingly. So just briefly how ACM works. I like to think that first thing this gives you is control over what workload. I don't want to cap the entire LPAR. I want to decide what workload to constrain. Even with batch, you may very well decide, well, this group of batch jobs are critical. They should never be constrained, even for budgetary purposes. They need to have full access to all the resources on the machine all the time. That's no problem. You can define that. When? If I have decided that a workload is eligible for capacity management, just because it's eligible doesn't mean it's always capped. That's like a resource group. You can cap something all the time, but why do that if your 4-hour rolling average isn't at a peak? You're not paying anything more for it anyway. Why not let it run at full speed? So you want to constrain that only when your targets are being approached. And then how? How do you want to constrain this workload? You can constrain based on concurrency, simply saying that, well, normally this group of jobs is allowed to run, say, 20 concurrently. But under these conditions, I'm going to limit that to 10 or 5 or none. Or if a job is already executing, there's not much point in trying to drain an initiator or use a manual method like that. But what ACM can do is automatically move an executing job from its current service class into a discretionary service class with a resource group limit that you have specified. And you can have various resource groups at various sizes and automatically move the work through those resource groups, essentially as you're getting closer and closer to your target limit, further constraining the workload. And of course, that's what we're talking about with the final bullet, is how much do I want to constrain? Do I want to cut the number of jobs all the way down to 2 or 3 or 0 for a given category of work? The resource group capacity, do I want to cut that down to, say, 10 or 20% of an LPAR, or perhaps 2%? Maybe I really want to slow things down. You have the control to make these granular choices. Now, here's just a quick example of what this looks like within the TM automation policy. We implement this as percentages of your target. So in this case, your target is, for example, 1,000 MSUs. Whether I have a cap or not, I've decided that I don't want to exceed a 4-hour rolling average of 1,000 MSUs. So your highest percentage, you can see at the bottom there, is 99.9, or effectively 1,000, and the action that will be taken by ACM. But we mentioned earlier when we were looking at the 1 o'clock in the afternoon versus the 9 o'clock CPU peak, we need to start early. We need to be proactive if we want to actually control the 4-hour rolling average. We don't want to wait until we get to 1,000 and then try and do something about it, because I can guarantee you can stop all of your workload if your 4-hour rolling average is just hit 1,000. That 4-hour rolling average will continue to rise. It's too late. So what we do is go back earlier. That's what these percentages are, 80, 85, 90%. Now, those are customizable percentages, by the way. You don't have to start at that particular number. You can set your number. But in this example, 80% equals 800 MSUs. So what that means is, before I reach my limit, at 800 MSUs in a 4-hour rolling average, I'm going to start taking some action. And there's some examples here of the type of action that you can take, starting with very low priority work and some modest constraints, and gradually increasing the type of constraints and the severity of the constraints, if you will, as you get closer and closer to your desired limit, thereby slowly, gradually pulling down the consumption of the selected batch work and lowering the 4-hour rolling average. Now, this is what this looks like in action. It essentially combines this into 3 primary phases. So in the early phase, as I mentioned, you're gradually constraining the lowest priority work. You're not at your peak yet, but you're approaching it. ACM detects that you're approaching it. It's gradually slowing down that selected work. You get into phase 2. This is where I'm at or even above my actual peak. During this phase, ACM is going to be constraining the workload to the maximum extent that you have specified within in the policy. So really holding the line on your budget requirements while at the same time protecting your most critical workloads by ensuring they have unfettered access to the hardware. The third phase is also important because you don't want to just, say, manually hold things back and then try and remember how to put Humpty back together again. So in this case, ACM will remember, oh, this particular workload normally runs in this service class. I had moved it to this resource group because of the policy. Now that I can see things are starting to come down, I'm going to move it back into its original service class. Similarly, with any concurrency constraints, if we've decided to reduce the concurrency of jobs down to 2 or 3 or 0, those restrictions will also be removed. So what you have is a smooth resumption of workload, essentially getting things going again while still keeping an eye on the budget. This is another example taking us back to that chart we saw before. You could see we peaked at 1 o'clock in the afternoon. That was the 4-hour rolling average peak in the chart in the top left. And this particular installation decided they wanted a 10% reduction in their costs. Reasonable, modest value. So they selected a 4-hour rolling average value of 265, plugged that into the policy, selected the workloads that they wanted the constraint and the level of constraint, and let ACM do its work. And as you can see in the bottom right, what ends up happening is this gradual selected reduction that I talked about, which gradually brings down the 4-hour rolling average. So the pink line now is a new 4-hour rolling average. It actually peaks a little bit sooner, but lower. And this gives them the savings they wanted while protecting those critical workloads. Now, we always like to say, well, what more can be done? Some other considerations. We alluded this in the abstract of today's session. All LPARs are not created equal. Let's face it, you very likely have different software products installed on different LPARs. At a very high level, this can mean, very simply, some LPARs cost more than others. Maybe you want to control individual uses of some LPARs or group them by applications. Maybe you don't want a soft cap at all. Maybe some LPARs are contributing to the 4-hour rolling average, as all LPARs do to a greater or lesser degree in the machine, but maybe because of business or other reasons, they cannot be capped. The point is, you might need some additional flexibility in how you can constrain your workloads and keep costs in check. Now, I'm going to pass the baton over to Selby, and he is going to talk to you about some wonderful improvements that we've made in automated capacity management that help you meet these goals in particular. We call them LPAR Sets.
Thanks, John. Let's start by explaining what an LPAR set is. Well, an ACM LPAR set is an installation-defined group of one or more ZOS LPARs that are on the same CPC. These LPARs do not have to be in the same sysplex, and each LPAR can be in more than one LPAR set. Note that this is an improvement on LPAR groups, where an LPAR can be in one and only one LPAR group. Each LPAR set has an associated 4-hour rolling average limit that is used by ACM. We will see that shortly. The LPARs in each set may also have a defined capacity and or be a member of an LPAR group, but it is not required. Later on, we'll have some examples showing how you can use LPAR sets with or without LPAR groups. And since LPAR sets are only known to automated capacity management, exceeding the limit for a set will not cause soft capping. Instead, ACM uses the LPAR set limits to trigger actions like John talked about, to limit batch workload demand to control the 4-hour rolling average. Along with other ThruPut Manager automation parameters, ACM LPAR sets are defined in the ThruPut Manager automation policy. The process is very straightforward. For each CPC in the JESPLEX, create your LPAR sets by giving them a unique name, selecting the LPARs that are to be members of the set, and setting the 4-hour rolling average limit for each set. Once you have configured your LPAR sets, You can activate the new policy using the policy dialog or an operator command. This can be done on the fly. There's no need to restart or drain any component. ThruPut Manager starts using the new policy on all members of the JESPLEX immediately. Should you wish to create new LPAR sets or alter the limits of existing LPAR sets, you can do so by activating an updated policy. If you are initially uncertain of what limit to provide for an LPAR set, you can tell ACM to monitor and display the 4-hour rolling average for the LPAR set, but not take any actions as a result. Once you have determined the limit, you simply update the policy and activate it. Every 5 minutes on every LPAR in the JESPLEX, ACM calculates the 4-hour rolling average for every LPAR set of which the LPAR is a member. If the LPAR is also a member of an LPAR group or has a defined capacity, ACM calculates the 4-hour rolling averages for the LPAR group and the LPAR. Next, ACM determines the percentage of each limit that has been reached or exceeded. The highest percentage is considered to be the most important. The installation specifies which batch workloads are to be constrained, as John talked about, and how they are to be constrained at each of the 5 different percentage levels of the 4-hour rolling average. The main idea is that as the percentage rises, more work should be held back. ACM uses the highest percentage across all the limits to determine which level of constraint should be applied to batch. For example, if one LPAR set is at 50% of its limit and another LPAR set is at 95% of its limit, ACM will use the 95% value. Also, as John explained earlier, ACM applies the constraints gradually to start reducing batch workload demand as the 4-hour rolling average approaches the limit. By the time the 4-hour rolling average is very near or at the limit, ACM is reducing batch demand to the full extent specified by the installation in the ThruPut Manager policy. Once the average starts to come down, ACM will gradually relax the constraints, allowing more batch workload access to CPU cycles. You can use LPAR sets on their own to reduce demand and lower the peak 4-hour rolling average. This is most useful in an environment where soft capping is not desired. In other words, there's no defined capacity or group capacity limit in the LPAR definition. Simply define and activate the desired LPAR sets to ThruPut Manager, and ACM will reduce batch workload as the average increases without any use of soft capping. John and I thought it would be helpful to show you some examples of using LPAR sets in different situations. So we're going to look at the following: grouping LPARs by software stack cost and by software product, using LPAR sets and an LPAR group, grouping LPARs by load type, the classic split between production and development, and finally, managing the 4-hour rolling average when there is a special LPAR that must not be constrained in any way. All the examples show LPARs in the same CPC. Of course, these solutions can be replicated across every CPC in the installation. Here we see an installation with several LPARs and a very typical list of major software products: MQ series, IMS, CICS, DB2, and of course ZOS itself. As is very common, not all products run on every LPAR, a strategy that on its own saves software charges. In this case, the software stacks have been categorized as high, medium, and low cost, with 3 LPAR sets defined to match these. The limits are set with the incremental cost per MSU in mind, allowing ACM to aggressively reduce batch load to control the high-cost LPAR. The low-cost LPAR on the right, LPAR 4, can be managed much more loosely due to the reduced financial impact. Obviously, the strategy for managing the set of LPAR 2 and LPAR 3 would be somewhere in between the other two. In this example, LPAR sets have been defined by the major software products. Note that since DB2 and MQ are on the same LPARs, these are covered by a single LPAR set. The SCRT report will show the peak 4-hour rolling average by product, which you can use to establish an appropriate limit for each of these LPAR sets, allowing greater control over individual product costs. This installation is prepared to use soft capping, and so we have implemented an LPAR group with LPAR 1, 2, and 3, where IMS, DB2, CICS, and MQ are running. LPAR sets are still defined to independently manage any batch load on the IMS and CICS LPARs, as well as the all-Z LPAR set of all of the LPARs. In this configuration, ACM will manage batch workload on LPARs 1 through 3 using the LPAR group limit, the LPAR sets for IMS and CICS as applicable, and the all-Z LPAR set. LPAR 4 will be managed using just the all-Z LPAR set. Soft capping will be activated by the high 4R rolling average on the major, more expensive LPARs, but not by the low-cost LPAR 4. LPAR sets provide additional control both at the product level and across all of the LPARs. Here we have an example where the installation has isolated production and development load by putting each on separate JESplexes on the same CPC. They want to control their software costs, but only constrain the development workload. In the production JESplex, there are no LPAR sets defined. Production work will not be constrained by ACM. In the development JESplex, an LPAR set has been defined that covers all LPARs. This will cause installation-specified development work to be constrained when the overall development plus production 4R rolling average approaches the desired limit. Production work, since it is on a separate JESplex, is not affected in any way. This arrangement has an additional benefit. It enables development work to run unrestricted when production is not busy and the 4R rolling average for all LPARs is not near the limit. Some installations have one or more LPARs which must be treated differently than others. For example, the installation may be contractually obligated to provide a given level of service, and the LPAR must not be capped or constrained. The work in the LPAR may even be from another organization or corporate entity. However, load on special LPARs still contributes to the 4R rolling average. So what to do? By implementing an LPAR set, as you see here, ACM on the other LPARs can reduce batch workload demand in reaction to the overall 4R rolling average, all without affecting the special LPAR. If desired, an LPAR group comprised of just the other non-special LPARs could be added. These examples should give you some ideas about how ACM could help your installation manage its 4R rolling average and reduce MLC charges. John?
Thanks, Elby. So I hope some of those examples have given you some ideas of how you could use LPAR sets to reduce your software costs. Obviously, you may come up with some examples of your own. Now, if you're wondering just how much you can save with ThruPut Manager Automation, just send us your data. What we'll do, we calculate the top 50 4-hour rolling average peaks in a month and calculate the batch contribution to those peaks. This provides a reasonable estimate of potential savings. You can't just look at the number one peak in a given month and figure out what you could save. That wouldn't work. But as you can see in the example here, you are talking about a significant amount of money once again. And we do find most of our customers see a return on investment in 8 to 12 months based just on IBM monthly license charges. So in summary, I'd just like to say this. As capacity management professionals, we know that we need to control costs while providing reliable service to our critical applications. We know what our most critical applications and budgetary limits are. But what we can't do as human beings is analyze and react at machine speeds to changes in workload demands and machine utilization while simultaneously holding the line on those budget limitations. With ACM, you customize your policy to meet your business goals and watch the automation work its magic. Here's our contact information. As we mentioned before, if you'd like to send us some of our data. At this point, I'd like to pass the mic back to Janine, and we would be happy to take your questions.
Thank you, John. We do have some questions that have come in, but I'd like to invite all our attendees to go ahead and to continue to submit questions. You can do that in the Q&A panel on the lower right-hand side of your screen, and please direct those to all panelists. Okay, John, how many LPAR sets can be defined?
How many LPAR sets can be defined? I believe the number is 8, but I will check with the man himself, Selby.
Yes, that's correct. You can define 8 on each CPC. So every CPC in your installation can have 8. So if you have 2, obviously you could have 16, and so on and so forth.
Okay. And here's one for me. Will the slides be available? I just wanted to let you know that the slides will be made available, compliments of our friends at ThruPut Manager. So be on the lookout for our follow-up email, which will go out early next week, and it will include a link to the recording as well as a link to a PDF of the slides. Okay, here is another question for Selby or John. With ThruPut Manager, do you still define service classes and resource groups in the WLM policy, or is it inside the TM policy? I hope I'm making sense of that.
No,
okay.
That makes perfect sense, and that's a good question. No, we're not reinventing the wheel here. You still define your service classes and resource groups to Workload Manager as you normally would. The difference is you don't classify the work directly into those. You simply provide those service class resource group names to the ThruPut Manager policy, and within there you specify when and how they're used.
Okay. How does ThruPut Manager control the 4-hour rolling average without using a soft cap?
I'm going to let Selby go with that one.
Well, it's simply put, it's by reducing demand, so that as we described in the presentation, as the load comes in, we classify it and we identify the work that you and the installation has said can be constrained. And when we hit that level of utilization, we start constraining it. And a couple of ways that reduce the demand are you don't run as many, so that's the concurrency that John was talking about. And the other way is to put it in a new service class that belongs to a resource group that has been defined in the WLM policy to have a maximum. And it's that maximum that constrains all of the work that gets put in that service class to a certain percentage of the LPAR. The resource group has to be set up so that it is system-oriented, in other words, LPAR-oriented, not sysplex-oriented, so that we can control how much CPU gets allocated. And the idea is that as the percentage rises, the percentage of the 4-hour rolling average limit, then you change it to use even a different service class with a more restricted resource group maximum. And so the amount of CPU that workload that you have selected to be deferred is allowed to access gets less and less. And so that stops the growth in the 4-hour rolling average. And as you saw in the graph that John had, it causes it to flatten out and prevents it from going through the limit.
Okay. How does this apply to the new CMP licensing?
Sure, good question. CMP stands for Country Multiplex Pricing. This is IBM's new offering where they've increased the sizes of the tiers for large installations. But the short answer is, to me, it can be even more useful in an environment like that because you no longer have these, what we used to refer to as shamplexes that are necessary. It's still a consumption-based metric and you still want to control your 4-hour rolling average as much as possible. In fact, I would really emphasize using ACM controls prior to converting to CMP, because the biggest gotcha, I'll call it that, with CMP is that your future price is based on your existing consumption. And there are some details to that. I don't want to spend too much time, but essentially you're going to set a baseline based on your current consumption to IBM, and that will affect your future pricing. Everything that you can do to lower that baseline prior to converting is going to save you money. And even once you've converted, you always want to be able to control that consumption. And LPAR Sets allows you to control it at a granular level on the LPARs that are more expensive, as Selby described.
Okay. In what release of ThruPut Manager did support for LPAR Sets become available?
LPAR Sets are available in the current level of ThruPut Manager version 7, release 1.
Are there provided controls to manage online workloads based on rolling 4-hour average in addition to batch? Okay, do I need to repeat that, gentlemen? Are there plans for NAS to provide a control to manage online workloads based on the 4-hour rolling average in addition to batch?
ThruPut Manager is designed to manage batch. It does not manage where online transactions go. So the simple answer is no. But the other answer is that we do put out messages as various thresholds are reached that could be used with an automated operator to trigger other actions to influence your online load.
Okay. Of the customer sites using ACM, what percentage of that customer base would you estimate is utilizing the LPAR Sets concept?
Well, LPAR Sets are brand new. We've got a customer that is using LPAR Sets today very successfully, but we hadn't really made a big, if you will, marketing splash about the particular enhancement. That's really what this webinar is all about, is to get the word out.
Yeah, and that installation is a very large installation. So it's had quite a workout, and it's been very successful.
Is ThruPut Manager appropriate for a customer who only has one production LPAR?
Oh, absolutely. Yeah. Because the way ThruPut Manager works within each individual LPAR, it's not necessary to have multiple LPARs in order to save money. It's still going to be measuring your consumption on that LPAR and reducing it accordingly.
Okay. How will ThruPut Manager help when the 4-hour rolling average is not a contributing factor for the pricing model used, if the pricing model is based on MIPS, DASD, and tape?
I'm not really aware of any pricing model that wouldn't take into account consumption, and the question does mention MIPS. MIPS is simply another term. The 4-hour rolling average specifically is a 4-hour rolling average of a metric referred to as MSUs, or millions of service units per hour. Millions of service units is another metric that you could use as MIPS, as CPU time. These are different metrics, if you will, but they all reflect the consumption of the workloads on the CPU. And unless you're paying for the capacity of the entire machine, you are paying for some level of consumption.
The other thing I'd point out is that the automation part of ThruPut Manager, the service level manager that worries about loading the system, can help reduce costs by allowing you to run in a tighter environment where it makes better decisions about what should run, what's the most important. And that component deals with the CPU peak usage as opposed to the 4-hour rolling average. So really, we can put the two things together. But if you have something where you're just concerned about the peaks, the automation part deals with that.
Okay, can ThruPut Manager run LPARs that are guests on ZVM?
ThruPut Manager is a ZOS software product, so we would not directly run in those LPARs.
Okay. Is it true that the systems that can be included in an LPAR set is limited to the systems in a JESPlex?
No, that's not true. The systems can be on, they don't even have to be in the same sysplex, never mind in the same JESPlex. An LPAR set consists of the ZOS, as many of the ZOS LPARs on the same CPC. And this is similar to LPAR groups. IBM LPAR groups are the same way. The members of an LPAR group also do not have to be even in the same sysplex. ThruPut Manager, ACM, is aware of the CPU utilization and the 4-hour rolling average of each of the LPARs on the CPC.
Okay. What shared DASD is required to use ACM?
Well, ACM is just a component of ThruPut Manager. ThruPut Manager has a control file in much the same way that JES2 has a checkpoint data set. So very small, shared access. That's really it. We're not talking about a lot of storage here.
And you're only talking about the JESPlex scope. So from the ACM side, there's no actual requirement for any shared disk at all between members in order to handle the ACM requirements, which is why ACM can see things that aren't even in the same sysplex.
Okay. Well, I'm going to throw this one at you guys, and you don't have to name names, but someone's asking you to compare your product to that of competitors in terms of, of similar products that do the same function. Can you identify the benefit? I'm not even sure anyone else is doing LPAR Sets, so I'll share that one.
No, happy to take that question. There are other products that work in, shall we say, the space of attempting to control monthly license charges, but we're not aware of any product that actually reduces consumption, reduces demand anywhere. There are products that work with soft caps, so you can take the defined capacity, group capacity limits that IBM provides, and those products will adjust those limits dynamically. But that does nothing to directly control the actual demand of the workloads, and certainly such a product would be precluded from working without soft caps. So I don't believe there really is anything directly competitive with us. Selby, you got anything to add?
I think that sums it up. We're the only people who reduce demand. There are some other products in this same general space that will dynamically change limits.
Okay, this is from a different person, but kind of ties in. What if I'm already using one of the third-party capping products already? So I think this kind of speaks to the whole idea of capping versus reducing demand. So the question was, what if I use one of third-party capping products already?
The answer is that we do work with them, and we are working with them. And so they can change the limits, and we reduce demand.
IBM offers online, read-only, and mobile transaction discounts. How would ThruPut Manager fit in this model?
Well, our pricing is very flexible, being a small company. I'm really going to leave that to the marketing folks to get into the specifics, but suffice to say that we're certainly fair and open to all sorts of options.
Is there monitoring that indicates when ThruPut managers dynamically constrain the batch workloads, and likewise when those constraints are lifted?
Yeah, absolutely. There are messages that are issued anytime what we call the capacity level, which is those percentages that we alluded to. So when on each LPAR or LPAR group or LPAR set, when the capacity level changes, you would be notified of that. And we have a lot of customers that are taking those messages and triggering on them to take action and so on. If you want to get additional displays, they're available. There's a lot of good information in that space.
In addition to that, we have commands that allow you to interrogate the data, and also as part of the analysis that occurs every 5 minutes on every LPAR, we put out an SMF record with the results of that analysis. So those can be looked at as well.
Great. And we do have more questions coming in, John and Selby, but I did want to let our attendees know that please continue to submit your questions even as we approach the top of the hour, because if we don't get to them here, somebody will be happy to reach out to you and answer your question via email. Here's the next one. Does ThruPut Manager require a significant amount of CPU overhead?
Oh, absolutely not. Nope. I've been in performance for a long time. I measure these things. And look at what Jez uses. That's about what we use. ThruPut Manager.
We don't do as much as Jez, actually, John, I would say. We spend a lot of time worrying about code path lengths and things like that. So the answer is no. It's very efficient.
Great. Okay, here's someone appreciating the answer to your previous question, but want some further clarity. Just to be sure I understand this completely, he says, the LPARs would have to reside on the same CPC in order to be contained in one LPAR set. Is that correct?
That is correct.
Okay. Do you need ThruPut Manager and all the, I'll start over. Do you need ThruPut Manager on all the LPARs in the LPAR group?
In the LPAR set? I think he meant LPAR set.
That's what they mean.
Yeah, he did mean LPAR set.
And the answer is no, you don't. And a good example is the special LPAR where it might be some other company's software, and they may not have licensed ThruPut Manager, which is a shame, but it happens. And you can still, on the other LPARs, they can still see the CPU consumption, and that LPAR can still be part of an LPAR set.
Okay. And I just have to chuckle because I apologize to that attendee who, right after he wrote LPAR group, said, sorry, LPAR set, that is. So he did clarify. Okay. Is there a charge for your MSU analysis?
Oh, absolutely not. No. Please send us your data. We've done a number of analyses for customers, and we're happy to look at your data and give you a reasonable estimate of your costs before you go down the road of installing any software.
Okay. How do I determine what the limits should be for my LPAR sets?
One of the ways you can do it is you can run them and see what they're coming in at and decide how much you want to lower them. The way you can do that is when you define them, you don't provide a limit. And so you can then interrogate or examine the SMF records to see what the peak usage is, what the peak for our rolling average is for a particular LPAR set, so you have some idea what it's coming in at, and then you can set a limit later. But while it's in that mode, ACM won't take any action, so there's no risk. It's simply basically in a monitor mode. If you've got your LPAR sets divided up pretty much by product, any of those, you could look at your SCRT and see on that particular CPC what the current peak for our rolling average is for the last, say, maybe look at the last 3 reports for the last 3 months. And that'll give you a good idea about what you're having now, and then you can decide, well, what would I like to lower it to? And then start doing that maybe in several steps, gradually lowering it to see how tight you can make it.
Great. Thank you. I'm afraid that's all we have time for today. Some great questions coming in. So I also want to thank our attendees for their participation today. It really adds great value. Thanks, everyone, for attending, and I especially want to thank John and Selby for sharing their expertise with us today. I'm still getting some questions about sharing the presentation with attendees, so just know that later next week, I should say early next week, we will be sending out a link. It will be a link to a recorded version of today's webinar, and there will be another link so that you can go ahead and download a PDF of the slide deck. That concludes our webinar. Thanks again, everyone, and have a great day.